In this tutorial, you'll learn how to set up a VVAX Metrotech Lock 10TX transmitter in order to use a SPAR in line mode. There are three ways to connect the transmitter to the line. The first is a direct connection, which is most effective when possible. First, identify an above-ground point on the utility line you want to map. Here we have a gas pipe's above-ground access point. The transmitter's red clip must be attached to a metal point on the line. Sometimes a metal point will be obvious, other times the pipe may be covered in insulation and a small point must be uncovered. The black clip must be attached to a grounded metal stake. A good ground connection is an isolated metal stake or large screwdriver driven into the ground at a right angle to the expected path of the utility. Metal signposts, often based in concrete, and chain link fences, which conduct signals along their length, are not good ideas for ground. When you place the ground stake, be sure not to place it near other lines or metallic fences or barriers in order to minimize unwanted coupling. To improve the ground connection, you can try these strategies. Ensure the connection point on the stake is not rusted. Embed a longer stake deeper into the ground to reach wetter ground. Pour a gallon of salted water over the stake before connecting. Don't use the SPAR within 10 meters of the transmitter for accurate location and depth measurements. Once the two cables are attached, press the power button on the transmitter. The screen will read the current frequency that the transmitter is outputting. To change the frequency, press the F button to toggle through the frequencies the transmitter is currently programmed to output. If the frequency you want isn't appearing, press the I button 5 times to toggle through the menu until you arrive at the frequency menu. Scroll through the available frequencies using the plus and minus buttons. When you find one you want, press F to select it. The transmitter only handles a certain number of frequencies in its active menu at once. To add a frequency, you may need to remove another one or multiple. ORI's SPARs support selected frequencies from 22 Hz to 9.82 kHz. How do you choose a frequency? Lower frequencies are always best when possible because they will have less distortion. However, the general rule is that if a low frequency isn't working, try a higher one. A low frequency might not work if the line is buried deeply, giving you a weak signal, or if the pipe is damaged, meaning the signal is grounding prematurely. To understand how to manipulate the transmitter a little better, let's take a moment for a quick lesson in electric currents. In this equation, V is voltage, I is current, and R is resistance. You control the current on the transmitter, which will in turn control voltage, but resistance depends on the quality of the line and the ground. Since the magnetic field is directly related to the current flowing through the line, your goal is to achieve a strong current in whatever conditions. With low resistance, you can work with low voltage and still achieve sufficient current. However, if you have a poor ground, you'll need to use a higher current, thus requiring a higher voltage. The transmitter's maximum voltage limit is 50 volts. If you're at 50 volts and the current is still very low, this would be a time to try a higher frequency or take measures to improve the ground for lower resistance. Resistance is measured in ohms. As a general rule, if resistance is below 1000 ohms, you can get good current at a medium frequency. Below 100 ohms, you'll get a good current at a low frequency. Above 1000 ohms, however, you'll need to use a higher frequency to get sufficient signal, because the SPAR is more sensitive at higher frequencies. Use the I button and the plus-minus buttons to view current, voltage, and resistance, and to change these if necessary. By pressing I, you'll also find a menu for setting a second frequency. The transmitter can emit 2 frequencies down a line simultaneously. Since you can change the frequency the SPAR reads from Utility Survey, this would allow you to try a higher and a lower frequency at different times while you're measuring the line, without having to go back to reset the transmitter. Keep in mind that total power will be split between these 2 frequencies. If a direct connection to the utility line is not possible, the second way to connect a transmitter is to use a clamp. The clamp's cable will replace the direct connection clips, and there is no ground cable. Clamps are most useful for pipes completely covered in insulation that cannot be damaged, or are an excellent way to connect to headers. To use a clamp, the target line must be grounded on both ends. The clamp works by electromagnetic coupling. It induces a current on a closed loop. So, you must connect the clamp below a nearby grounding point. The transmitter, when turned on, will recognize that it is connected to a clamp. A transmitter using a clamp only supports 3 frequencies: 8192, 8440, and 9820 Hz. The third way to connect the transmitter is using its induction coil, located on the bottom of the transmitter box. This method allows a signal to be applied without access to the line. Placing the transmitter on the ground, with the handle aligned with the utility, will induce a current on that nearby line. Again, the transmitter will recognize that it has no cables connected and will activate induction mode. Only 3 frequencies are available, the same as using a clamp. This method is not recommended, as an induced current can easily couple to other metallic lines and structures adjacent to the target line. A few warnings. First, never use a spar to locate closer than 20 meters from a transmitter in induction mode, since the transmitter has an airborne signal that the spar will locate. Second, never place the transmitter on top of a manhole cover or metal plate, since the signal will not induct all the way to the line, and may in fact damage the transmitter.